NTR's advantage in specific impulse over chemical rockets. Manned space exploration is a challenging task. Humans are affected by weightlessness, psychological stability, and radiation. The greatest factor affecting all of these variables is time. The longer astronauts are in space for, the more they will be affected by these issues. So, for modern exploration to planets such as Mars, 55 million kilometers away, we need a rocket engine faster than our current chemical or ion engines. There are many potential technologies that have been suggested: matter-antimatter annihilation rockets, Kugelblitz drives, and even superluminal, faster than light, Alcubierre drives. But unfortunately, all of these are far future technologies. There is, however, technology that already exists today which can be utilized to deliver humanity to other planets faster and more efficiently than chemical rockets: nuclear thermal rockets, or NTRs. First, some math. Specific impulse, measured in seconds, is equal to the exhaust velocity, measured in meters per second, divided by the constant of standard gravity. Specific impulse is the measure of how efficiently a rocket uses fuel to generate thrust compared to the rocket's mass. The greater the specific impulse, the more efficient the rocket will be. Chemical rockets have a maximum specific impulse of 500 seconds. NTRs, however, have a specific impulse of around 850 seconds to 1000 seconds, although theoretically the specific impulse of an NTR can be up to 6000 seconds. Now to the physics. Chemical rockets rely on combustion of fuel to create thrust. NTRs use fission. Nuclear fission is the process of splitting the nucleus of a heavy atom such as uranium by firing a neutron at it and splitting the nucleus into two lighter nuclei, additional neutrons, and heat. In an NTR, this reaction occurs in a honeycomb-shaped array or matrix of nuclear fuel rods. The hydrogen is pumped through this matrix, and the heat generated by the reaction in the nuclear fuel rods is radiated into the hydrogen. Now, because the exhaust velocity is proportionate to the temperature of the fuel over its molecular mass, the greater the temperature of the hydrogen, the greater the exhaust velocity will be. So by using smaller particles at higher temperatures, an NTR will have a greater specific impulse than chemical rockets and will allow humanity to reach the other planets faster and more efficiently than our current method.